Hello and welcome to the third video, which talks about the typical measurement locations. So far we have covered the basic of the purpose of this course, and in the last video, the types of instruments and equipment that is needed to conduct a successful power measurement. Now let us look at the typical locations and where one would connect the measurement leads and CTs. We will also look at the correct points for current measurements to get accurate readings of the full load being consumed. Let us first discuss low voltage measurements, which is going to be the more likely scenario for most people. Now, this typical low voltage single line diagram gives a good starting point of where you would want to connect your voltage leads and current clamps. As you can see, the above panel will be equipped with its own voltmeter and ammeters with a set of 500 to 5 amp CTs as in this example. So here we have the voltmeter and ammeters, and we have the CTs with 500 to 5 ratio. In this case, if you were to measure the main incoming supply, you could use the current clamps of your own, or you could use the transducers connected to the secondary side of the panel CTs. The best place would be onto the wires at the back of the ammeter, 5 amp maximum on this connection. So you could either bring your own current clamp with a 500 to 5 ratio or higher, or you could use the secondary of the panel CTs that are on this panel, and you have a 500 to 5, and you could connect to this 5 amp and you can use your transducer to get the readings. If you are measuring the total load at the main incoming supply, take careful note of this scenario and ensure that you measure on the bus bars directly below the main circuit breaker or above the main circuit breaker, and not anywhere where the various feeder wires connect to the bus bar. If you measure below the feeder offtakes, some of the current may have already split from the bus bar. So let's have a look at this picture. What we are saying here is we either measure at the top of the breaker or measure at the bottom of the breaker, but not here on the bus bar because you already have outgoing feeders from this bus bar. So you will not get an accurate reading. Let's have a look at this picture. Same scenario, and you do not want to measure down here. This is incorrect. Okay, those two are correct. If you want to measure the power on one of the feeders, you would have to use your own current clamps and ensure that the clamp's primary rating is more than the circuit rating. So here we go. If we want to measure the current on one of these feeders, then we would have to connect our CT onto this feeder. Now remember, just don't use too high rating clamp. Example, on an 80 amp feeder, do not use 1000 to 5 amp. It is very likely that the load on the 80 amp circuit may only be about 20 to 30 amps. And using a clamp with too high a rating may give resolution issues, resulting in poor accuracy. Using up to 250 to 5 amp is probably the most I would go with. However, it does depend on your instrument and its capabilities. The voltage connection is quite simple, and you could connect to the main bus bar or at the top or bottom of any circuit breaker. Just ensure that if you connect to the load side of any circuit breaker, that the breaker is not likely to be switched off. Otherwise, you will not get any voltage readings. So if we look at this scenario here, connect your voltage leads here, or connect your voltage leads here, or you could connect your voltage leads to any of these, whichever is the most convenient. And we've already talked about this in the previous video. So I think we've covered that area and it should be quite easy to understand. I'd also like to show this as a typical electrical panel where you have your main circuit breaker down here and you have bus bars. So these are quite the older type of panels. You have bus bars and then you have panel ammeters and voltmeters. And this is where you could typically also measure your currents. It's better recommended to measure your voltages from the bus bars or from maybe a feeder circuit breaker. But to measure your current, it would be quite convenient to measure at the back of these meters. Now, when we come to medium voltage measurements, it is quite different. For medium voltage equipment, one cannot simply connect the voltage leads to 11 kV points or place current clamps around medium voltage phase cables for obvious safety reasons. That is why medium voltage cables are inaccessible. Here is a typical 11 kV protection panel. Now, in this type of panel, firstly, to get the voltage readings, you would have to determine where the three-phase voltages come from the voltage transformer. Typically, protection equipment operates via step-down voltages of 110 volts. So the voltage transformer, or VT, would be 11 kV to 110 volts. In South Africa, we typically have them labeled with ferrules as E1X, E3X, and E5X, where X is a number 1, 3, 5, 2. So these are found inside the panel, and you might find them at your terminals here, or you could find them coming onto your voltage selector switch, which would be somewhere here inside the panel. And that's where you would get your 110 volt supply for each phase. Now, I typically use the flycatcher, or what we talked about, the micro clips. So you might use the micro clips here, and you might want to connect to those voltages using the micro clips. And this is where they enter the terminal block. Now, for current measurements, there is no other choice but to use transducers, because the only place current readings can be obtained is from the secondary of the metering CTs inside the medium voltage panel. So if you have panels, M meters, then you would typically connect, and let's assume this is the M meter, you would typically connect your current transducers here. So this is typically behind the M meters, and they would be labeled D1X, D3X, and D5X. Note that the connections C1X, C3X, and C5X are for protection CTs. It is better to measure on the D connections for better accuracy. So metering should be D label, and then your protection would be C labels. So let's recap what we have covered in this section. We've covered the low voltage measurement locations and the connection points. We've also spoken about the medium voltage measurement locations and their connection points. Now, in the next video, we'll be looking at measurement parameters and instrument configuration, on-site connection and safety, instrument configuration on-site, and reporting. Thank you, and I'll see you in the next video.